Okay, let's get going here. We need to, let's see, load file into memory, convert U08 memory to U32 memory. So there's a lot of stuff we need to do here. And we're calling standalone main twice here. Why are we doing that? So we need to figure out converting this U32 array. We need to convert it to a U08 array. Right? And then we want to save the file. We're saving the file. Okay. So we save this file to disk. And then we are going to load it from disk. Or not load it from disk, but we're going to take that file we just saved to disk and we're going to convert it into a hex dump. And then, once we convert it into hex dump, we're going to convert it back. And once it's converted back, we have to convert it back into, I'm not sure exactly what I need to do to get this working, but hold on, before we, here's what we're going to do. We know we need some more code here, but we're not sure exactly what needs to be done. But we're absolutely sure that we need... We're absolutely certain that we need this function, right? We need a function where we're going to be able to convert that U32 array to a U08 array. So we're absolutely certain that this is something we need. And, oh, also, before I... push-ups. I need to make sure... I mark having done my push-ups as well, so I need to get to that as well. So this is the main function, command line helper functions. I don't know exactly where we need to put this code here. Command line helpers. File reading and writing. Could go before this, I guess. File reading and writing. Saving the file to disk. Private API helper functions. Does it belong in here or not? I don't know. Just put it here. Let's call it like, I don't know. Could call it helper functions I didn't realize I needed. So that is a very big section name. And then we can post this function here. Right? And now we have this section. Yeah, sure. Why not? Why not call it that? Just because we're not sure about exactly where we want to organize this. And so just throw it in there, and I think that'll be good. Now, before we get to this, on my push-up screen, I just did 130 push-ups before I got on stream. I played Doom and did my push-ups, and I also jumped on the trampoline, which is good because 500, so that means we are at that puts this at 630. And I did 130 today, so I don't even need to change that. But it's Friday. I did my 1:30 when I got up. So Friday, video 127, video 127. Okay, I just wanted to clear that up before I go here, because I got everything done before midnight. So what do we need to do here? Well, first we could fix up this signature, right? And we're going to keep it a public function because I think that we're going to need this utility. We're going to need this utility for I don't know. I could see it. For some reason I want this to be public in terms of usage. The idea is if I use this HEXDUMPER utility to encode byte arrays into the source, but the byte arrays are encoded as, you know, uint32s, then we're going to have to translate that. So I can kind of see a reason why I might not want to encode things as uint32 arrays. They need to be byte arrays, like, because now we have a static array, and it's not usable in its file scope allocated format, and have to allocate more memory just to use it. So that's a problem. So what we could do, I don't know, but let's just write this. Here's what we're going to do. We're going to try to write this and finish it before midnight so we can push something up to GitHub and have a GitHub commit contribution thing. But let's just get this going, right? So let's say, you know, we want to assert that U32 pointer 0 is not equal to U32 array, and we want to assert that U08 pointer 0 so these should be by reference here, and then we want to make sure that these references are not null. And then also when we dereference them, we want to check one more time. And when we dereference, we want to make absolutely sure that these are null and 0. So, right? Okay. So these are input checks. We also have to set the type on here as well. So this U32 array, right? This is just a U32 pointer to this array. And then let's actually tab that in. And then over here we have a U08 pointer, and then we have a int32 pointer, or int32. And this is by reference, so by ref. And this one is also by reference. So these are both by reference arguments, or formal parameters, whatever you want to call them. So we're going to put a little pointer thing there to indicate that, and line that up. So we just want to line these up with the output, line this up with the input. U32 pointer. So U32 array, U08 array, right? We're turning the U32 array to U08 array, and this, we have to have a way to return the size, right? So then this will be void here. We want to define U32, we want to define U08, and then we want to also define I32. So I32 we could do up here. Then we could align that a little bit nicer. And after we have that, we can put some checksums in here. Right, so make sure that we have the number of defines that we think we have. Even though 3 is not something we really need to count. In the sense that we can glance at 3 things and we can know that those are 3 things. Now, different people have different capacities for being able to group and count things, right? The ability to instantly count a certain number of things, right? You don't have to count 1 thing, right? You instantly know that it's 1 thing. You don't have to count 2 things. You can instantly know it's 2. You don't have to go 1, 2 to know it's 2. Same with thing with 3 things. Most people can do 3 things. People can do 4 things, right? And instantly know it's 4 things. And then after that, it's kind of like it depends on the person's brain, right? Dare I say, the more mathematically smart you are, the more you can, the better you can like track multiple groups of things and count them, right? So, I don't know what that is. I think it's like there's some type of like mathematical part of the brain where like the ability to track multiple groups of like objects, to track multiple like objects moving across the screen, and being able to track those objects, figure out how many there are, things like that. That raw power of being able to do that is highly correlated to mathematical ability. So those people who are like really good at first-person shooters, there is a question as whether the first-person shooter made them that smart, or if they just had a natural ability to be good at first-person shooters because of their ability to track multiple objects. Okay, so what else do we need to do here? So we're definitely gonna need to loop through everything. So core logic. So we're gonna label this as core logic of function. We're gonna give it like a little boulder of a section. Alright, so core logic of function, and then return via output params. So we're going to return via output params. And I really should make some type of script to help me make these sections. So all we're going to do is, by ref U08 array equals U08 array, right? So we'll figure out what those are. And it is going to be our job to free this memory, right? So, the idea is that I don't want to have to so you can make something where, you call the function once and you figure out how much memory you have to allocate, and then you allocate that memory. So the malloc and free can be done in the same scope. And I like that. I like that idea of doing it that way, and I definitely do it that way sometimes. However, the problem with that is then you have to do a 2-pass. You have to do 2 passes. You have to go over everything once you have to call the function once to figure out how much memory to allocate. Then you have to call it one more time to allocate the memory. Now we still have to do 2 passes here, but we don't have to call 2 functions, right? We can do those 2 passes in the same function. Or actually, we don't really need to do 2 passes, right? Because all we got to do is say, hey, take the U32 array, and whatever the size of that, we just have to multiply that by 4, right? So now that I realize that, hey, well, wait a second here. We need to know so input so this is the array data, and this is the array length, right? So right here, array data, array length. We have the same deal over here. We have array data, and then we also have array length. That's fine. So let's so we're going to declare and allocate variables here. I'm not going to consider that the core logic. That's just like one of the things we have to do before we get into the algorithmic goodness. So also, if we have this variable here, then we also need to check that, right? So we need to assert that 0 is not equal to U32 length, right? We need to make sure, or not even that, but we need to assert that 0 is not greater than or equal to, right? So 0 or negative is still bad. This is also a length variable right here. So for this, we also need to do the same kind of thing here, where we actually want to 0 greater than or equal, right? Because it's a length. So we have a... So actually, hold on, I'm wrong there. Not equal to, and then... Oh, actually, no, this has to be 0. So, so the inputs and here's the outputs. So the inputs need to carry something valid, right? So can't have a null pointer, and the length needs to be something positive. But for the outputs, we need to make sure that the references are not null. And then we also need to make sure that when we dereference them, so this is not a dereference. So when we dereference them, let's dereference that. We want to make sure that when we dereference, same deal, we can make sure that when dereferenced, they're pointing to zeroed out things, because they're not filled yet, right? They're not filled, so we want to make sure that they're in a zeroed out state, so that we're not accidentally overwriting a pointer that's already storing like valid memory addresses. Okay. So if we're declaring these variables for the U08 array, right, we're going to say, like, you know, U08 pointer, U08 array, and that's just going to equal, let's put the length up here first, or actually, let's do this, let's calloc something. And the number of elements is going to be the U32 length times 4, and the size of U08. Right? And then for the U32, or int32, which is U32 length, the length of the U32 array, that is going to equal, if you haven't guessed already, U32 length times 4, right? So the reason I'm writing it this way, rather than putting U32 first and then referencing U32 in here, is just that I like to keep this order of we have the array and then we have the length. We have the array up here and then we have the length. So I want to keep that kind of same thing going on. So array and then the length. And also this is not U32 length, this is U08 length. It's the array of the byte array, right? So U32 length times 4 gives us these. Okay, cool. So now that we have everything allocated, we're just going to say, you know, for dex equals 0, dex is less than or equal to the max index, and then dex plus plus. I'm going to just set up like a little core loop here. And we also need some type of variable for the index, so let's say int32 dex. And we don't really care what it is right now, and then int32 max index, however, equals the U08 length. But then we're going to minus 1, right? Because we want a max inclusive index. Okay, so once we have these, we can start looping through everything. However, I think I changed my mind on that. This index actually would be easier. It would be easier to loop through the bigger thing. Be easier to loop through the U32. So instead of the U08 length, we're going to take the U32 length to loop through here. And we're going to say U32 max index, and we'll call this like a U32 dex. And it's kind of confusing because this U32 is not Hungarian notation, right? It's not saying U32 I32, right? That's not the purpose. It's this is the index keeping track of a U32 array, right? This is a max index of a U32 array. So if you want to make a note of that, 127 and the time is 22:33. Not Hungarian notation. U30 index of a uint32 array. So, the idea is that this is not Hungarian notation. That's why this int32 doesn't match this. If that makes sense. So, let's we can make a note of that. Okay. So now that we have that, we're going to change things around, right? We're going to say, this is going to be U32 dex, and then this is going to be max index, right? So U32 dex and U32 max index. U32 length is inputted here. And so what we're going to do is we're just going to say, you know, U08 array U32 dex times 4. And we're going to just unroll this and just keep it as simple as possible, which means we are going to over-calculate things more than they have to be calculated. But, equals, so this base offset, let's just call this, let's keep a base offset, let's call this base, so that way we can do base equals U32 dex times 4. Alright, this is the base offset. And then we can do base. The only reason I'm making this, I'm not actually doing this to save calculations, it's just that I want to make this a little bit more compact. So this is the base offset, and from this base offset, and we're going to take the U32 array and the U32 dex. And already I'm like, I don't like that. I'm gonna change this around again. And this over here is U32 dex. I'm gonna just make this shorter because I'm not liking how much column space it's going to take up. So this dex here, we're just going to have to know that this is the U32 dex. And then this is the max index. So U32 index times 4 to get this base. And this U32 array, we're just going to have to keep it like that. We just want to shift it out 24. And after we shift it out 24, we want to go and 0xFF. And let's just define some things. So let's just define some things to make this a little bit shorter. Right, so the array, and then we mask it. So 1, 2, 3, right? There's 4 bytes per uint32. And this is the output array, right? This is out. Yeah, this is the output. So 24, 16, 8, and 0, right? So we're going to shift them out and then mask it with 0xFF. We need to make sure that this is 1 and the shifts look okay. I believe this is on the right side. Sometimes I swap these values and these values, and the compiler doesn't complain, and it gets really annoying. But yeah, so I think that's all we need to do to shift that out, you know. And so, you know, most of the stuff is just boilerplate. So now the next question is, do we have enough room to just type this out as is? So we could do this, right? Where we just have ARR. Do you have enough room to just type it ARR instead of U32 array like that? And it's not quite correct, is it? Let's do this. Out is this thing, right? This is the output. And the input is this U32 array, right? So let's do in and out, right? So inputs and outputs. We're taking the inputs and transforming them into outputs. So define in as this, and then we'll undef in, and then undef out, like that, right? So in and out. And then we can keep this shorter, but then we can also keep it a little bit clearer, because right now this is wrong. And this is the outputs, right? So the outputs are 4 different bytes, which we extract from a single uint32, right? So here's our input with this UD times 4, and we might actually have enough room to where we don't even need to use that base value if we can. Right now, obviously, we're kind of recalculating something multiple times, and so it can be kind of like a wasting. I don't know if this actually wastes, if this is more processing heavy, because we have to recalculate it, rather than just calculate it once. But if I can get it all in one piece here, I think it's more readable. So U32 dex, the max index is the U32 max index. So now the thing is okay, we have this thing here, and we definitely need this to be UD, just because otherwise we're not going to have enough room to write everything in a terse manner. But we could say U32 max index here. We can get rid of this base value, and so we can just get rid of the base offset value, and we can change this to, we can change this one back to its U32 whatever the heck. Yeah. So U32 dex, U32 max index, which is U32 length minus 1. That looks good. UD. Yeah, so pretty simple, right? We just shift out. We're doing network byte order. So the byte in the most significant position gets this address here, because we want to read right, so this is network byte order. So let's make a little comment here about what the heck's going on. Network byte order. And so 0x A, B, how about 01, 02, 03, 04, comma, 05, 05, 06, 07, 08. And then we can say, you know, 01, 02, um, 01, 02, 03, 04, 05, 06, 07, 08, and right. We can try to put that kind of in the middle-ish, like that. Right, and the idea is that, right, everything is kind of being distributed I was gonna have to leave that to, that's the best I can diagram it. I think I'm just gonna keep it like that. So yeah, it's network byte order, right? So that's kind of how we're extracting things, if that makes sense as a diagram. I don't know if that does, but it helps me kind of understand how we're doing things. So we're gonna keep that as a little note, and then we'll make a little note of where this was at vid IID. So, okay. So network byte order. So this output is the U08 array. Now, do we malloc the memory? Because it doesn't look like we mallocked any memory, did we? Or did we calloc it? No, we callocked it up here. We're good. So also what would be nice to do is maybe have like a thing that counts the callocs and the frees. But probably not in a public function, though. If it's a public function, then we can't control if everything is malloced and freed in a balanced manner. If we're going to let other code execute this calloc function, so we can't wrap this calloc function if this is a public function, because then we have no clue what the usage is going to be. So the idea is that if we wrap the callocs and the frees, and the mallocs and the frees, and then we have like internal code to count, right? To make sure that if we allocate memory, we want to make sure we free it, right? And if we wrap these calls, we could have checks for that. But we can't really get away with those kind of checks if this is going to be a function that is public, and therefore this calloc, we have no clue when this is going to be called from like other code externally, right? Because if this is going to be called from other code externally in unpredictable ways, then this also gets called in unpredictable ways, so we can't really balance our callocs and frees by just wrapping them in our wrapper function and then using some counting logic to balance it all out, if that makes sense. Okay, so that looks like a decent function to me in terms of the logic. Is it correct? I don't know. We'll have to find out, I guess. So we could have like a little check and say that let's just assert U32 max index no, that's fine. We're good. Yeah, that's fine. Okay. So yeah, now we have this thing here. And this also needs to be zeroed out, because my function is going to complain if things aren't zeroed out. The idea is that I want to make sure that we're not accidentally overwriting memory. So we're going to require that if we pass in something that needs to be passed in by reference, that it's pointing at invalid memory and the length has also been zeroed out. And we're just going to do that as a little protective feature of how we use our code. Okay, so we have this. And then once we've converted it into a byte array, we can convert it back into the original PNG, right? So we can save it to disk, right? So the whole thing is that we need to and right here, save file PNG, we got a U8 array. We got U8 array, we got the link. So this should be everything we need to do to get it on disk. So we'll put that back in, because that looks proper. And are we missing something else? So let's just make this into a section. So we have the original data here, right? And this is actually a PNG file. Convert save hard coded data as PNG file. So we want to save hard-coded data as PNG file. That's what we're doing here, right? So unpack. So we're gonna unpack so we want to unpack into byte array. Then save PNG Alright, so we're going to save the PNG bytes to a PNG file. And then over here, I know people say, like when I was doing work at ArenaNet as an intern, they said, don't number your things because those numbers are going to change. I say, I disagree with that. It's a trivial thing to change the numbers. And more often than not, the code is not going to change. Because if all the code was changing all of the time, you would have a problem on your hands, right? Because we're always adding more and more and more code, and if it was all changing at the same time, eventually we would get to a point where it would be impossible to do any. Okay. If you can only do 10 units of work per day, right? Or let's normalize this. You can only do 1 unit of work per day, and then you work on the code base for 10 days, and it has 10 units of work in it. Well, we can't just start changing everything in here, right? Like, the idea that some of the things are going to change, and so don't write hard-coded comments is just stupid, because it's not all going to change, right? Sometimes a few things might need to be changed once in a while here and there, but not everything. Because if everything were to change all the time, you would never be able to get new work done. Does that make sense? I don't know if that makes sense. So, we're not gonna... So, declare a PNG byte array. So we're going to declare the PNG byte array. We're going to unpack into byte array. And then we're going to save PNG bytes into PNG file, right? So that's what we're doing here. Okay, so now that we have this PNG file on disk, we want to try to run our standalone main. So we're going to create these arguments. So we're going to ignore the first argument because it's not a user-supplied argument. We're going to do PNG converted to a naked array, right? Because we have this, this is the naked array thing, but we just hard-coded it in here, so now it's not a naked array. It's actually a whole bunch of bytes encoded as U32. So we're gonna change that PNG to naked array, right? So the actual PNG bytes to naked array, or no, it's PNG file to naked array. So this UTC PNG right here. So let's, yeah, and then we're going to change it to UTC TXT, so that makes sense. And then this argument count is 4, sure, that's good. Standalone main, we're going to just do this argument count in the argument array. So what we're doing here is we are we're loading the PNG from disk, right? So convert PNG on disk to text file. or we're converting the PNG on disk to a text dump. That's what's going on here. And I need to do drugs. So I'll be right back. I'll be right back. So let me commit this really quick. So I want to make sure that I have contribution history every day. So I always want to do just a little bit of code every day, so I have at least one contribution. So I just wanted to push that up there really quick before I go take a break here. So I'll be right back. Should take me about I'm going to give it 6 minutes, and I will be back. Okay. Ooh, that's hot. I'm gonna just come back so I don't think anyone's watching. Just close this. Okay. So, yeah, we're gonna convert the PNG on disk to a text dump. on disk. And then we're going to do the opposite. Convert text dump back to PNG file. So we're going to convert this back to a PNG file. And so this is going to be naked array converted to a PNG. We're going to take the UTC TXT that we saved. We're going to turn it back into UTC PNG. Right, here's our argument array that we just created over here. The argument count. Now the argument count, we have to change that around, don't we? Because we need to actually use that everywhere, right? So arg count, right? We can't use it here if we just undeft it, right? So let's say let's just go up here and define arguments, 4 of them. So we're just going to make a macro. We're going to call it A4, which is kind of like a really terse kind of thing. But I'd like to just keep all my macros to 3 letters if I can, because otherwise I just think it looks kind of ugly. But yeah, now we got A4 is 4. And then over here, anywhere we see arg count, we can just go A4, right? There's 4 arguments. We can get rid of this thing here. We can just put this here, A4, and then we have this argument array. So A4, and then argument array. And we can just make this a little bit terser, right? We can just be like, there's our thing. A4 argument array number 1. And then right here, we can get rid of this nonsense here, this here, and then we can say, hey, this thing is going to be A4. This thing is going to be A4. We can kind of clean this up a little bit, and we can say, hey, you know, that's a little bit too fluffy in terms of how we're writing the code. Let's kind of write it like this. And yeah, so this is the second arg array. Okay, so what's all this stuff? Load file into memory, convert U08 memory to U32 memory. We did that. Compare U08 memory with original array declared at top of test. So we need to compare with the original test. And the only way we're going to be able to do that is if we can... right, so here we have like save file, right? We need a load file PNG as well. Right, so we need to so right here, let's take this for a second, and load PNG file into RAM. So we want to load the PNG file that is on disk right now into RAM. So we need a load file command. I don't believe we have a load file command. And so we're going to have to make one. And then what we want to do is we want to compare the bits of this file once it's loaded. When we load the file as a PNG file, we're gonna let's not call it load file PNG. Because we do want to load a PNG file, yes, but we don't want to think about, oh, does it need to be compressed? Does it need to be decompressed? So let's call it load file U08, because we actually want to look at the actual bits. And then we're going to call this one I'm going to just call this a got array. We're going to call this got len. And we actually want to just pass it by reference because it's going to be filled out by the loading function. We also need a memory cleanup array, right? So we need to clean up some memory here. And what we need to clean up is we need to free the U08 array, and then we need to free the got array. So both of these arrays we're going to need to free. So got array right here, and then the U08 array, it's made right here. Here's where we're populating it. Yeah, so that's what we need to free. After we exit this function, I'm not going to worry about... We could say that, you know... We could say this as well. It doesn't really matter because we're exiting the function right away. But maybe it's a good habit that we should just do anyways. To say that, you know, equals U8 pointer 0, right? Just null it out. Same thing with the got array. So got array equals U08, right? We could null it out here as well. So free the memory. What else do we have to do? So we load it into RAM, load file into RAM. So now we need to compare, right? This compare right here. So both arrays should be identical. So both arrays should be identical. If they're not identical, then somewhere we screwed up. So we're going to say that, both arrays should be identical. So this right here, make sure unpack works. Make sure U32 to U08. So we should probably make another section in here where before we exit this section, that's kind of weird because we could put this check anywhere, but we don't have any tests for it, so we should write a test for this. We want to make sure that taking a U32 to a U08, it works. And so we're going to have to take this function here, and we're going to need the inverse. So Right now, does this function actually exist? Yeah, so this function that we wrote, we're going to need the inverse of it to properly test. So we're just going to say this will be U08 array, right? So we're going to change this to U08. And we're going to convert it to a U32 array. Already I see some problems. For example, this needs a fourth parameter of U08 length, right? So this U32 array right here also needs a length. And we need to check the parameters there. So U32 length. Do we have that as a parameter already? So let's go up here. So we got this array here. Well, this array just is not being declared correctly. We need to know what the length of this is. And I really don't want to have to count, but I guess we're going to have to count, aren't we? So we can still keep a note of this, right? So this is Decton logo binary as U32 array, whatever. And we need some type of number here. Technically, we don't need a number to get this hard-coded in, but if we want to run our test, we're going to need to know what the length of this is. I don't trust... Pointer decay makes me paranoid, so we're not going to try to just use the size of. We're just going to say we're going to keep like a little checksum here, right? We're going to keep a running total here. Or not. Control copy. Alt select. Control V. There we go. So this is kind of messy. But it's important, it's very important that we know exactly what's here, right? So 12, 13, 14, 15, 16, 17, 18, 19. These are 20s, so let's just do this. 20 something. And now here's a 30. Let's just call this 31. Okay, so the first thing is we need to make sure that this checksum is correct, right? So, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 38. Okay, so I'm fairly certain that this checksum is correct. That indeed this is 38 lines. In fact, this says 38 right here, and it starts on 2,401. So the line numbers also confirm that. So we're absolutely sure that we have this many, right? So now that we know that, we can say, you know, if we have 37 times 1, 2, 3, 4, 5. So we got 37 times 5 plus 2, right? Yeah, plus 2 left over. Let's just get a calculator. 37 times 5 plus 2. So 37 times 5. And then plus 2. 185. 186, 187, right? 187, okay. So, assert that 187 equals this calculation here. So this is just my way of, you know, let's make sure our math is correct in case we are being stupid for some reason, right? Okay, so now that we have this, we're going to say, we can't really say, I'm just going to call it, let's just define it here, I guess. Define U32 array len, right? And that is going to be 187. And then we're just going to say assert that 187 equals this number here. All right? So now we can put that number right there. And for these variables, this U32 array length, you can just put it up here. So we could say int 32 U32 len equals, and then U32 array length, right? So just have it nicely lined up like that, so we can just see absolutely certain that these two kind of go together, if that makes sense. And then we can just color code these really quick, make sure that we can see those two numbers there, and indeed we can. So here where we flipped everything around, that's not really what we want, because we're just going to call this U32 array CHK and U32 len CHK. And we need that because we don't want to alter this. Well, it's, first of all, it's hard coded here, right? This is already allocated, so that could create some problems for us. Yeah, so right here, let's just say U32 pointer U32 array CHK equals U32 pointer 0, right? Null that out. And then int 32 U32 len check, right? So these are check values. And, you know, if the U32 array, the U32 len is not equal to U32 len check, then so then we're failing this conversion here, right? Okay, otherwise we want to say, you know, for I equals 0, or int 32 I equals 0, I is less than or equal to, or actually let's go I is less than U32 len, and I plus plus. And now that we know that we have the correct links, we just want to say, okay, well, here's our array. If, you know, this value here is not equal to the U32 array, if these two are not equal, then we have a problem. And so we'll just say error. So we'll just tag these and say, this is the first failure message, this is the second failure message. And it's in between square brackets, so we know it's a hard-coded message. So yeah, we just want to make absolutely sure that this conversion works. Because if this conversion here from U08 to U32 doesn't work, then we can't be confident that this data set here, when it's converted to a byte array, is the correct data set. So once we can confirm that works, so we're going to have to write this code right here. So I'm going to come back to that. Then we're going to convert the PNG bytes, right? The PNG on... Hold on. Oh. Yeah, because right here, so right here we save it. Let's actually indent this a little bit more. So the problem here is that this section can kind of like go anywhere. And right, so we have this thing here, and we have this kind of thing kind of stuck in the middle here, which just kind of makes things confusing. So slash star star slash. Yeah, so that should work. We're just gonna make a date timestamp here for the fail message because it got too long on us. So we'll just, that'll be our message, right? So we're just putting this in here like this. So, right, we're gonna open up a multi-line comment and then close it immediately. So even though this looks like it's commented out, it's actually active code. The idea is I just want to be able to see save bytes to PNG file. Yeah, because this is save hard-coded data as PNG file. And that's where we're doing it right here. So once we have that on disk as a PNG file, right, we want to take the PNG on disk and convert it to the TXT file, right? PNG to TXT. Invoking the command line, the standalone main command line. Then we want to do the reverse. So once we have that text file, we go text file to PNG, right? So naked to PNG, so the inverse command of this. And we're going to resave that PNG file, right? And let's change this around. I think that what might help is to have two PNG files, right? So let's say we try to do this conversion thing, but the first PNG file, it gets saved to disk. But then when we try to overwrite it, it doesn't actually get overwritten, and so we think the test works, but it doesn't actually work. So let's try to avoid that, and let's just call it UTC let's just call it 001 PNG. I'm going to change my name to 001 PNG. And so we're going to save that to file. We're going to convert 001 PNG to 001 TXT, right? And then we're going to take 001 TXT right here, and we're going to convert it to 002 PNG. Then right here, we want to load this into the memory. So we're going to say 002 PNG. Right, so we're going to load that. And then we want to make sure the bytes are identical, because we're loading it as a U08, so the bytes should be identical to, not to this, because we loaded it as a PNG, but right here we have a U32 to U08 array, so this U32 array should be identical to whatever we just loaded in. And Yeah, got array is what we're using here. So you have got an array, but we also have one other thing we need to clean up, right? So this check value needs to be cleaned up as well. So okay. So for, you know, int32, I equals 0, I is less than or equal to, not this thing, but to the original U32 array. And we just want to if this array is not equal to this gotten array, right? So we load the file from disk, right? And when it's on disk, it's just a U08 array. I don't know if that's the best message, but good enough for now. Yeah, if that doesn't match, then we're in some type of serious trouble. And the last thing we want to do is we want to take this function here, and we want to do the inverse of that as well. Oh, actually, no, this is right here. U08 array to U32 array. So this is the check right here. So we already kind of made sure that that works there. So if we can know that we can convert from here to a byte array and back, then we don't really have to take this array and also convert it back to make sure it checks. But we could do that for just a little redundancy if we really wanted to. Overkill check. So let's just do it anyways, just in case. Like, the tests are supposed to be redundant, and sometimes you'll write, like, an extra test that you're like, I don't really think I need to do this because the other thing we just did already proved this, but sometimes you'll be surprised. So what we're going to do is we're going to take this gotten array, right? So this is, we just loaded this file from disk from the O2 PNG. And so we want to take the gotten array, which also has a gotten length, got array and got length, right? Now, did we actually declare those anywhere, or are we just making those up on the fly? It looks like we might be making them up on the fly and not actually declaring them anywhere. So we're going to have to declare those somewhere. We don't have a variable declaration section. That's fine. I think I like the way I'm doing it so far. So this is the first use case here. So we're going to say declare it where it's near where it's used. So this is a U08 array, right? Because it's PNG file, yeah. So U08 pointer called got array, and it's going to be, initially it's going to be a null pointer, right? So, and then we need int32 length, so got length, and that will initially be zeroed out. So there we go, got array, we got length. Okay, so then this is going to be, let's just call this got array check and got array length. And then we'll just say free got array chk, and then got array chk equals, the gotten array is going to be u32, so u32 pointer 0. Then right here, we'll say, you know, u32 pointer got array chk equals u32 cast, or u32 pointer cast of 0, and then the int32 length, got array length, equals 0. Oh, hey! So, God, it's been a long time since I've actually used Japanese. I can tell that's ko, ni, chi... Oh, I'm gonna guess you're saying konnichiwa. It's been a long time since I've read hiragana. But yeah, how's it going? I can also explain why my name is Kanji Coder as well. Since you might be curious to know why my name is Kanji Coder, though I haven't used kanji in any of my code for quite a while. It's kind of like an experiment to make like really terse variables. So for example, like I had a command prompt that was called like dragon, and so I would use like a combination of apps Hungarian and systems Hungarian, and I would mix them together to create really terse variable names like tdragon. Right, like this, and then dragon would like stand for dragon would stand for my like command prompt class, right? So it would be the dragon command prompt, and then I would have like for like wrapping stuff, for like a modulus. I had like a modulus class that handled like wrapping around the screen logic, and so I would use like wrap, I believe, or not that kanji. I kind of forget where I was storing that. It was a different kanji. I can find it. Hold on, like actually, if I type modulo, modulo. Yeah, I use this one for like a wrapping class. Right. So I'd be like looking up different kanji and their meanings in like Jisho. Like you probably are familiar with like jisho.org. And it would have like, you know, I'd look up the definitions for different kanji and find like the one that's like the best fit for like a certain class I was using. And I would just like do this to make my code like very terse and very short. And the other idea was that, well, if I do my classes like this, no one can make assumptions on what the code does. So a lot of times people will kind of like grope their way around code, and they'll use IntelliSense to kind of like guess what code should be and just kind of like autofill things out and not really know the system architecture. And so I thought, well, if we make all the class names kind of these obscure names, then people have to actually go into the class and like read about the class before they can use it. That was kind of like the hypothesis there. Now the problem is that there's a massive amount of front loading you have to do when you code like that. So you can check out these demos, or here, I'll just go show you these now if you're still here. Let's see, it takes a little while for my server to boot up because it's a free server, right? So it's on Heroku. So this game I made about 8 years ago. It's like Bomberman, except Bombs have different directions. Bombs are proximity mines, so you can pass through them and they don't block your way, right? That when you pass by a bomb, it kind of lights up and blinks for a while before it explodes. Also, bombs have a little bit of delay when they go off, so they cause chain reactions, unlike Bomberman, where everything kind of like explodes all at once. And then also, some geometry has physics on it, so when you're destroying the level, you can kind of watch things kind of fall apart. There's a whole bunch of other mechanics as well, but that's the basics. I'm very obsessed with tile maps, so I'm right now trying to write a fractal auto-tiling engine, where I auto tiling past its, I guess, 2D retro video games origin, you could say. So I really like auto tiling, and I think that you can really polish auto tiling to a level where you don't have to use retro graphics. So that's what's kind of going on here. Is I'm using like shader code, GLSL shader code, to create these kind of like shader-based tiles, right? And so when you lay down one of these tiles, you can kind of zoom into it, and you can still see all this good detail, right? So, and then we can also zoom out, so we could say make everything 16 by 16, and then, right? So everything looks kind of nice, no matter what level of zoom you're looking at it. And what else do I have here? And I'm going to check the chat really quick. Yeah, so I don't think you're, well, if you're here, you're here. Rendering engine I made with ActionScript for tile maps that have multiple layers. The idea is data leverage, where the artist creates one level map and then we can render it in multiple ways. So this is the same map rendered in a style called Foggy Morning. Then this rendering setting is Sunset, and this one is Starry Night. Obviously not a very original name, Starry Night, but, you know, it's just names that I can use that make sense, right? So data leverage is the idea that that you get the most bang for your buck out of your data, if that makes sense, where the artist only had to work on this one piece of art here, and then we could just apply different settings to it, and we've just multiplied their work effort by 3 here, right? So they only had to work on this one thing, and now we have 3 pieces of art, right? So data leverage, if that makes sense. So with a lot of modern games, they take more and more work to make assets. So as somebody who is not a AAA studio, we have to think about, well, how are we going to make something? How are we going to compete? And we can't compete in the same way. So I think designing an engine with the idea of let's make it as easy as possible to make assets seems like a good goal in mind, to be able to productively make assets and turn them out very quickly. This is the lighting engine I made for the old game. Loading screen I made for the old game. This is in Golang. And it's just a little tile editor. And this is something that's not going to go into the engine because it's triangle based. So it's just like a little quad tree used to like make snowflakes. I could describe it more, but you can just go to this and you can click on it, right? Subdivide it. It'll randomly choose colors as you're subdividing it. And then you can also click and drag to like really kind of like, woo, like that. So that's really fun stuff. Some other stuff. Anyways. So I'm going to put this back up here. And now I think I'm going to have to relearn my hiragana, so that next time somebody says konnichiwa to me, I know what they're doing. But yeah, it's just been such a long time. Okay, so right now I'm writing some unit tests. I'm trying to get assets into the engine by creating hex dumps of PNG files and then encoding the data into arrays. So, okay, well, I can just go up here, right? So this data right here is a hex dump of a PNG file. It's a hex dump, but the hex dump is in a uint32 format, so hence a uint32 array. And it's like a logo, right? It doesn't really matter what it is, but we're just running some tests on everything to say, okay, I'm going to take this hex dump I just made, and we're gonna just put it back into, we're gonna save it back to disk and then load it back into the game and make sure that saving and loading, we still get the same data out. We're testing our conversion functions, if that makes sense. Anyways, I kind of lost my place because I went on a tangent there, so I have to kind of recollect where I was here. So this gotten array, okay, that looks good. So U08 array to U32 array. I believe I just already wrote that code a while ago, or I guess I did not. So you know what I did? I wrote the opposite. So I think I have U32 array to U08 array, but I don't have the opposite function, right? So yes. So I have this function here. And I don't know if we want to call it helper functions. I realized I didn't need it. I think we'll just call this U32 array to U08 array. We're just going to double label this section of code really quick. And U08 array to U32 array. Okay, and then we'll just go down to the bottom of this section, and we'll just, you know, we could keep this label as well. Why? Excuse me. We could keep, you know what? We could keep this label as well. So, keep this label, and instead of just deleting that label, we'll just kind of triple label this section, which is kind of ridiculous, but why not? So, yeah. So these are helper functions I didn't realize I needed. U32 array to U08 array, and U08 array to U32 array. So, this code I wrote, we just need to write the inverse function of this. So, let's just kind of steal this here, this signature, or I guess this prototype. And let's just rename some things here. So, we really just want to swap the types here. So these types need to be swapped. And then these types need to be swapped. So this is U32 now. And this is U08. And this is U32. Okay. A lot of this we could probably get away with just taking all this stuff and just, I think cutting and pasting it might actually be the easiest way to do this. Where we can kind of copy this and we can paste it into here and just rework it a little bit. So right here we just need to change these from U32s to U08, right? So U08 array, U8 length, and then this by ref is going to be a U32. So U32s looks good. And the next thing is we want to go down here, declare and allocate variables. So this U32, this is going to be, so what we need to do is we need to look for anywhere we see this cyan or orange, we need to just flip everything. So this is going to be a U32, and this is going to be a U08. And in order to get this, we're going to have to divide by 4 instead of multiply by 4. And we're going to have to get size of U32 instead. And then this is also a U32 here. So we can say, this looks done to me. We'll just say, yeah, U32 array, U08 array divided by 4, size of U32, U32 length, U08 length divided by... Okay, so that looks good. So we're going to get rid of this kind of commentary here because that was from where we cut and paste, so we'll get rid of that. And this index here is now going to be... it's still... it's still going to be easiest to go over the biggest thing, I think. Yeah, it's still going to be easiest to go over the biggest thing. So now this base value is not... Oops. Hold on, let me go back down here. I screwed that up. This base value, this is... Okay, we're going to put that back in. Yeah, so let's just put that back in. So the base value is like a base offset. So in let's just call it bow for base offset. Base offset. And base offset here equals this. Right, so UD times 4. And that's right, so UD is going through the U32 decks. So we could say, you know, you could also, you know, assert could also assert that those calculations are correct, and then we'll change this to base offset. Right, so we could also just keep this as... Here, why don't we just change that to base offset as well, right? So base offset, right? We're looking at 1 int 32, but that's not quite correct, is it either? No, that's not quite correct. The... Oh, I see. God, my formula is all screwed up here. Base offset needs to go by 4, right? We gotta multiply by 4 here. This should not be multiplied by 4, right? Because this is, we're going through this one at a time, right? The input is the U32 array. These are our bigger chunks, and there's less of them. So, UD, right? Right, so... because we're being kind of stupid here, we should probably assert that base offset divided by 4 equals UD, right? So base offset divided by 4 equals UD. So we're just going to add these little checks here, because we don't know what we're doing. So we're at video 127, and the time is 38, 40, 50. So we just fixed this algorithm really quick, because we didn't know, we really screwed that up. So that's good to know about. And now that we're back up here, we can look at this and say, okay, well, that's great. So this UD here is the U32 dex. We're going to go through the U32 dex, max index, U32 length. Now the thing is, U32 length, okay, we calculated it here, so that's fine. We allocated the U32 array here. Okay, that's good. Now, this comment here, we're going to get rid of this. Network byte order I'll just, we'll just kind of do this, where we'll keep this kind of long comment here, but over here we're just going to keep a short little comment. And so the output this time, the input and the output is swapped, right? So the input is the U08 array, and the output is the U32 array. All right, so here's our input right here, and then the output is this U32 array. That also means that this needs to be U32 array, and this needs to be a U32 array. All right, this has to be changed as well. And that looks good to me. So now, because the output is a U32, we need to swap how we're writing these index accessors. So we can still kind of like keep this base offset calculation and put this in here, right? Might as well have the checks here as well. And then, you know, int32 BO for base offset. Okay. And this output is, the output is the U32, right? Yeah, output is the U32. So this base offset is not, we have to swap these index accessors, right? This base offset is multiplied by 4. Right, it's stepping by 4 and then going through each one of these components, so that actually needs to be swapped. So we need to take this and put it over here, and then we need to take this and put it on the other side. And now I got to think about this shifting logic. Is this correct? So we notice that, oh, this times 4, this times 4. We're not going to overwrite the same thing multiple times, right? What we are going to do is we're going to, we just got to shift some things around here, right? So instead of this, right, we want to go like this, in this direction, right? We want to pack them in. And it's already a U8 array. There's no need to use this mask here, right? Get rid of this, and then let's just put like a 0x, 1, 2, 3, 4, 5, 6, 7, 8, all right? Let's do that properly. And we can even say, you know, U32, right? We could even do a U32 cast of that if we want to be like super proper about what's going on here. And then we can bitwise OR this together like that. And bam! Okay, so somewhere I got my bracket balancing wrong. It looks like right here. So let's remove that. Okay, cool. So now we're good. The next thing we might want to consider is, I don't know, is our math correct? I mean, that's, so this index is going through every single slot in the uint32. Excellent. Okay. Now, if we're going through every single slot in the uint32, then what is this nonsense here? Why do we have ud times 4? Right? Why are we multiplying this by 4? And are we doing that over here as well? Are we being stupid here as well? No, we're not being stupid here as well. So somewhere when we were shifting things around, we got a multiplication by 4. Oh, because it was we pasted that code before we fixed this code. That's what's going on. So that looks good. But this UD times 4, it should just be UD, right? It's because it's the U32 dex. Now, because we have enough room, we might just want to call it U32 dex, because I think we have plenty of room to where we can just take anywhere where it says UD. We have enough room where we're not going to violate the column limit if we just kind of like make that a little bit more verbose, right? So, might as well. So we can just change that back, and then we can put a little comment /UD, right? So if we ever change it back to UD, we have no matter which variable we use, this variable or this variable, we'll have it in the comment here to know what its alias is. And we might want to line some stuff up a little bit since everything is now kind of shifted out of place. Maybe we put the multiplication symbol like that. Looks good. Okay. So I'm fairly certain that this is correct, but I have known in the past to screw this up many times. So bitwise OR means that if you combine 0 with anything, right? It's OR means this or that. So 0, 0 equals 0, 0, 1 equals 1, 1, 0 equals 1, 1, 1 equals 1, right? The truth table. I like to think of the OR as just smashing all of these together. It is kind of confusing because what I mean is I want to take this and this and this and this and just merge them all together. And so it's kind of weird when you think about it, because if you think about it in terms of English, you want this and this and this and this and this. You want to smash them all together, but you got to make sure that you use a OR to do that. So I always make sure that this is correct, because I always make that mistake because of the way the math works and how you would say it, kind of like sometimes is kind of the inverse. So this output looks about right. The output is this U32 array, and here's our by ref output there. The input is this U08 array, the input. The input we step by 4, right? So the U32 index we step by 4, so that we can offset into each individual byte of that byte array. Okay, so that looks sensible. That looks like a sensible conversion. So we're just going to say, dash line I1x64. And then what we're going to do is we're going to go over here, put that there, and then we're going to put this over here. And just kind of divide up these sections nicely. And do we have any errors in here? No, we're not throwing any errors. It just has some asserts. We got U08, I32, U08, I32, and U32. So that's all there. Okay, so I'm fairly certain that that is coded correctly. Might be getting a little bit crazy with these labels here. Okay. Is there anything else I'm missing? Well, I mean, the only way to find out if there's anything I'm missing is just try to compile. Well, we need an air macro. That's one thing we're missing. Int32 and I32. So define I32. And do we have like a U08? I'm guessing we are using a U08. Yep, we're using a U08 in here. And then we also want to define air. I don't know where we want to define it, because I feel like this kind of argument would be best up here. I don't know. Let's just put it here. Define air. as AAC 2020 PHEXDUM, and then it's what is it? It's just like halt. So let's line these T's up. I don't know how else to align it. That seems to be good for me. And then all right, so we got 5 of, oh god. I hate it when it, like, right, like I was somewhere and now I don't know where I am anymore because the, that's why I need a little bit of extra space here when I'm clicking around. So hopefully we didn't, click drag something. That's the one thing I really hate with, this editor. Like, I like Notepad++, except for the click drag thing, which you cannot turn off. Like, I've looked into it multiple times, and it's one of those features you cannot turn off, and it's like, you know, there's tons of good things about Notepad++, except clicking and dragging text. It's like, why would you let me do that? Like, when is that actually useful? And the answer is, it's never useful. It's like, it's just this, like, feature that lets you screw yourself over once in a while. Just, like, let's look that up for a second. But if we go into, like, turn off click drag Notepad++. But I'm going to write this down again. Turn off, in my notes, turn off click drag NPP. Turn off click drag Notepad++. Turn off click drag Notepad. Anyways, there is no way to do it, but I just want to search for it again. Disable mouse dragging of text, right? So this is what I want to do. And I'm pretty sure that we had to do it in like you have to do like a registry hack. And I tried the registry hack and it still doesn't work for me. What languages are you working in that randomly moving a letter in a file doesn't cause a syntax error? And it's not about this. It's about accidentally completely nuking your script, working in it for a few hours before you try to compile, and then, oh crap, when did I do this, right? Yeah. The general answer seems to be no. So I guess the answer might be like, text editors like Notepad++ that don't drag and drop text. So Sublime. I don't know, we could ask on Facebook maybe, I don't know. But yeah, that really annoys me. Like, I like a lot of stuff about Notepad++ except for that. So we're going to, I guess, give this a run? Yeah? This test code, we're not calling it from anywhere, are we? I don't think we are. Okay, yeah, let's just write. First step, first, right, compile it, right? Try to see what our syntax errors are. I assume we made some. If we didn't, I'm going to be surprised. Unknown type name, UO8. So on 451. So let's go to Control G and go 451. Is this in the function file? Yes, in the function file. 451, we got UO8. I thought we made the type dust for that. Did we not? Uh-huh. Oh, I see. And are these macros on a section by section? Yeah, so we'll just put a UO8 here and say, you know, undef UO8. And this was just a, this function is just a wrapper, right? Save file PNG. We also need a load file function, which we haven't created yet. So we're gonna have to figure that out as well. So we're going to put UO8 at the top of this section, right? So and then we'll just kind of slide everything up. And 06. And what next? Yeah, let's just keep on going until we can get this running. And conflicting types. So did we declare this twice? So this is the thing we made as a save file txt. So really, so this wrapper is really what this wrapper is save file UO8 is what this is here, if we really think about that. Right, we're just saving the actual bytes. Yeah. And that also means that in our test code, this save file PNG should really be save file UO8, right? Because we're not saving a PNG file, we're saving save file UO8. So save file UO8. Right, so we're going to directly save the raw bytes to disk, and we're going to save it as a PNG file, right? And then later we need load file UO8. There we go. See that even makes more sense already. So okay, let's look at this again and see what complaints we have. So eventually we're going to see a complaint that load file doesn't exist, but AAC PHEXDUM UO8 array types lack a cast 901. Okay, so Control G. Let's remove this extra space. And let's look at 901, right? So 901. And yeah, so this is kind of cut and pasted from the other code we worked on. And we forgot that Now this is going to be a U08 pointer, right? A U08 pointer, U08 array, right? This is these are U32 arrays, right? So this needs to be a U32 pointer, and this needs to be a U32 pointer, right? So U32 pointer here. And did we get that wrong down in the other input checks? And we did. So U08, this thing needs to be, when we dereference this, it needs to be U08. And also, we still kind of have this screwed up, because this reference is a pointer, right? It's a pointer here, because it's by reference. And this one's not a pointer, it's just the first one, right? So this is a pointer. Alright, so let's just kind of give it some visual space here, right? So we want to make sure the references are not null. Then we want to dereference these and make sure that they are properly zeroed out. So this is actually int32, right? So int32 cast is 0. This is actually a pointer. So that makes sense. Now let's go back up here and check this out again. Because I think, well, let's keep it like this for a second. So this array here and this length, this is a pointer. So first, let's kind of divide this up again. So a pointer, and then when we dereference it, we've got to remove one of these from each, right? So this will have 1 now, and this will have 0. So int32 cast of 0 equals this thing when it's dereferenced, the length, and the array, it's just an array. Okay. So that looks like I fixed those casts. So hopefully that makes sense why I have those input checks. That actually makes it harder to look at. Let's just keep it like that. Okay, undeclared first use in functions. So we have some more problems here. 997. So look at 997 really quick. This U32 dex is, it doesn't exist, right? It's just called UD, right? And I think at some point I may have wanted to change this, right? Because we could put, like, we could fill this with U32 decks, and we would probably have enough room. To write all this, right? And then we could get rid of this. Right, but we could expand this, and we still have enough room, right? U32 decks. Let's just get rid of that, because that's kind of pointless now. But then let's change around that check there, right? And then that also means that this will be, we're going to change this back to U32 decks over here, right? I know we keep on changing our mind. So the input here is a U32, right? Then this base offset, it's stepped by 4. So that we can get each single component that makes up one of these Uint32s. And we're extracting the U08 array, okay, and that's why there's 4 different accessors here. Okay, that makes sense, okay. That looks good to me. So let's go back up to the other one and look at that for a second and say, hey, did we get that correct, or did we screw that up as well? Sure, that's fine. Sure, why not? Okay, so let's just give that another run and see expected before token. So let's go to 2568. And right here, it looks like when we cut and pasted, we just kind of forgot to fix that up in terms of the formatting. And here's the data we're going to save. Here's the array, here's the length, and we're going to save it to here. That's fine. That looks good. Okay, so let's try again. So load file U08. So this function doesn't exist yet. So yeah, we need to actually create that file, that function. And we should be able to, like, do we have a, do we have any other load file functions, or is it just like, we know we need this? So we have this, like, load file if exists, and load file if exists is probably what we want to use, right? The input path, and then we decide if it's a PNG or not, right? Load file if exists. So yeah, I think this is what we want. Yeah, so load file U08 is going to be kind of like a wrapper for this function here. So load file if exists, right? So it's really like a file access wrapper. File access wrapper methods. File access wrapper methods. So yeah, we're gonna create a little section here. And we're gonna call it like, what do we call this? Is this like a, what type does it return? Does it actually return a U32? Which is like, I don't know why we're returning a U32, but if we look at this, we can see what we return here. Do we return like a success variable? No, we don't even return that. We just we're always returning 0. Unless we have a return early. So we don't really do anything with it. We probably should. If that's the way we want to do it, then we can kind of say, okay, it's some type of error code. Let's keep it as U32 here as well. So we're going to say, you know, U32 AAC 2020 PHEXDUM load file U32? No, U08. Load file U08. So we're going to say load file U08, and load file U08 is going to take a char pointer to we're going to give it a char pointer name of file with extension. Name of file with extension. Also known as file path input in other places. But name of file with extension, I think, is a more explicit. And so then we're going to say, U8 pointer. Okay, so basically we're going to have this here. File memory, file number of bytes, right? And we're going to call that U08 array, though, right? We're going to call it, yeah, so we'll call this, call that U08 array and U08 length, right? We're going to be more specific. And then within here, we'll just wrap this, right? And we'll just say, one is... we changed that around, though. We used enumeration, didn't we? So... over here, we have some enumerations. And... I believe this payload file type is for bin.txt, I believe. Yeah, payload type, right? Payload type. Payload file type is a PT, right? Yeah. So we're going to use payload type. So load file if exists, and let's make sure that this load file if exists, if it takes that thing, those bin.txt, how does that affect things? Yeah, so it's still not doing any fancy like PNG decoding stuff. That's fine. Okay. So that's fine, doing this here like that. Let's just define So we're loading a binary file. And these things here are just going to pass them on down. And we also need to get rid of these signatures here, right? We don't need that part. So file path input is going to be name of file with extension, right? So also known as file path input, but we're going to use name of file with extension, right? Name of file with extension is a little bit more specific. In our notes file, we might want to just make a note of this, right? So we have a notes file here. We could also say, we might want to put that one. That's a pretty complicated. So nofwex means, right? Name of file with extension, right? And then fipin means file path input. But yeah, just documenting it here might be nice. All the variables are represented, and then we just need to use this flag here, right? So, and I don't know, it's just a wrapper. I mean, I think that's all we need to do. We could also do some asserts here. You know, we could assert really, if it has an extension, name of file with extension, that means it needs a dot, and then something dot something, right? So the smallest thing it can be is it needs to be 3. A dot A, right? Right? So that's the shortest possible file path is something like that. So it needs to be at least 3. For the other stuff, we want to just assert that that this is not nil, right? So U08 pointer cast of 0 is not equal to nil, right? And then same thing here, int32, this is the int32 pointer. I want to make sure that's not nil. Copy paste that. We want to remove one of the stars from each one of these and dereference these. And then once we dereference these, let's kind of like wrap them a bit and say, hey, does that look good? So, you know, check inputs. And we could also check outputs if we really want to, but I think that I'm paranoid enough, and we should be fine. But yeah, we're just wrapping this. The load file, if exists, doesn't actually return anything. Well, we could say int32 or u32 useless return value because not implemented. Right, we could make it kind of obvious that useless return value because not implemented, right? Make it kind of obvious that that is not implemented, right? So let's make it 23 to keep with the conspiracy. Make it return value is not. So maybe in the future we'll implement it, right? Because right now we don't have any type of way to say, hey, if this file doesn't exist, you know, return some type of flag that tells us a non-zero flag would be nice for when there is a failure to load, right? So non-zero flag would be nice when there's like a failure to load. Otherwise, right, we don't want an IO error to signify to do something catastrophic. And right now, with the way it's coded, that's what could happen. So yeah, we got this load file function. That looks good. We need to do U32, U08, and I32. Okay, so define U32, define, let's define I32, and define U08, or U08. So we'll define these all right here. And what else? Let's just remove this commentary here so that we can have room for a checksum. And then down here, we can kind of undef all these. And yeah, that's the way it needs to be done. I'm just making sure that's correct. And we just want to get this compiling. Once we get it compiling, we'll solve anything that kind of seems kind of basic, where it's like, of course, that's a problem. But we just want to get things compiling and then get out of here. So do we have a char pointer somewhere? Yes, we do. So this right here is a char pointer type. Okay, we need to define that. So define chr. Do you have a thing for that? Yeah, const char. So most of the times when we say char, we mean const char. And so that's why my macro uses const char like that. Okay, let's give that a shot. Comparison of distinct pointer types lacks cast. So somewhere we got this wrong. So on 902, let's go look at that. 902, this is a U08 array. So here's what we did wrong. And not only that, we want these to be zeroed out. Or actually, we want these to be non-zero. But when we dereference, we actually want these to be 0, like that. Okay, so that looks good. And somewhere 924. So, oh, yeah, it's just pedantic. It's being pedantic. Got it. Two 651. So we can go a little bit further now. 2651. So it looks like just a problem from cutting and pasting, right? We cut and pasted the function and we forgot to just rewrite it like that. Okay, we got len check, whatever the heck. Got len check is undefined. So this is got array. Oh, got array check, and this needs to be got len chk. So this overkill check here, right, we need to actually do something with it. So we got this here, we got this here. This is the gotten array. We're converting it to U32. So now what we're going to do is right here, we want to loop through the original data. The original OG data up here. Alright, so this U32 array. We're going to say... Okay. For int32 I equals 0. I is less than or equal to, or is less than U32 array length. We're going to use the actual macro here. Actually, I might not be able to do that. Where is that to? Is that immediately undefined? Define U32 array length. It's right here. Did we not undefine it at the bottom? That's kind of bad. Yeah, but we want to undefine that right here. Okay, cool. So we're going to use this and I++. And it's a really simple check, you know. If this thing here is not equal to the thing we just extracted here, this conversion here, then we have a problem on our hands. So this gotten array Sure, why not? We just make the error name. And also, before we even go through this, we want to say, you know, if the U32 length, so this U32 length, is that up here? Do we have that? Okay, we have a cluster of just highlighting things. We need to get rid of that for a second. So this U32 length, is that anywhere, or... Oh no, it's this right here. So if U32 array length is not equal to got len check, then error bad length check. Okay. So if you can get this compiling, well, that looks good. So let's just try to run this program again. And then we'll worry about the unit tests tomorrow, I guess. About, like, invoking them and seeing if they actually work. So, PHEXDUM.exe, and we're going to do PNG to TXT, or PNG to naked text. And if someone does to TXT, we should have, like, a suggestion for what they actually want. But for now, let's just keep it like this, PNG to naked array, and we're going to do logo.png. Okay, so now you have this text dump. Now if we go over here, it's going to say it changed. I got this nice little text dump, right? Now, if we do the same command again, but instead of, we do naked to PNG, right? We take this and convert it to PNG, and we do PNG or txt.1234, or 1.123, right? So we're going to take this file, and we're going to try to convert it into a PNG file, right? So take this and hit enter. Is it going to overwrite the original file, though? Well, let's give it a shot. Yeah, so it overwrote the destination was the same as the original file, right? Because it used the default file for this. And that's fine. Now, if we close this, right? So close that. So that file we created is this file right here. And if we change it to change the extension, right? We change the extension to .png, and then we double click this. Open up. We double click that, so you see PNG or txt.png, right? It's a PNG file, right? So we actually have the PNG file. Awesome. So that conversion function still works. So right now we have code that works. I think the worst possible situation we could have in the future is having written all of this unit test code and then never invoking it because we just kind of forget about it. So, for now, we're going to how about let's make this private. Then let's make a public version. And the public version is going to be able to ignore you if it's already ran. We're gonna just say, you know, so over here we're just gonna say like PHEXDUM. Let's keep it private. PHEXDUM, or actually, sorry, AAC 2020. We really just need a U08 for this. So has the unit test been ran before? That's basically what we need it for. And then over in this code, we can say, you know, if this is greater than or equal to 1, ignore call. Already called. Else, we're just gonna say ran or running equals 1. So we're gonna flag this as running. Then we're gonna call it a private version. We don't really care what we call this with. We could actually call it with this U32 here, right? And then we're just gonna return something, we don't really care. Okay, so now with this, what we can do is we can try to insert it somewhere in the main kind of like standalone main. So standalone main. Temp. So the other thing we can do is, even though we already have a guard, it doesn't hurt. I think it doesn't hurt to call that guard, to use the guard more. Even though we already used the guard inside this public thing, to use it again, I think makes sense. So if less than or equal to 0, ran or running, right? So if it hasn't been ran before, only call unit test if test has not been ran before. right? So now we have a way to kind of lazily invoke a unit test, and lazy we can print that off to the console so we can see that when we start up. I need to take a quick break. So let me see if we can get this done right before I take a quick break, though. So let's try to get this compiling first. So /PHEXDUM.sh. We'll try to get this compiling first. AAC, PHEXDUM, unit test, whatever the heck. So that unit test needs to be forward declared. So let's say, you know, takes a U32 and returns a U32, right? So it's an extern, so we could use ext for that. And then we could just define it up here. So define and then the 7th define in this section is for extern, right? So ext is the 7th. Okay, yeah, so that looks good. U32, whatever the heck, unit test, blah, 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 unknown type name, U32. Okay, so that's just because we have a lot of stuff in here. We got character, we got int32, but we don't have a U32. So we need to define that somewhere. So let's say define U32. And if we're going to have to rework this, we might as well kind of shuffle everything around and categorize it a little bit better. So U32 and I32 are next to each other, which makes sense. These next to each other also make sense. I mean, that's not a bad ordering. I mean, yeah, I mean, that's not too bad of ordering. I guess it might... Yeah, sure, why not? Let's just leave it like that. And let's not worry about it. I think that's fine. And now we have these 8 things. U32 is above care. So actually, let's just remake the whole thing, right? So rather than worry about inserting it, let's just blast the whole thing away. And let's undef. And let's just kind of rebuild this whole list, right? So let's just kind of 1, 2. Okay. So, implicit declaration of this thing. So this is the private function. So let's go look at that for a second. So yep, that indeed that is beneath. So, let's say EV. Let's use EV for extern void here, because I don't want to write the whole thing. Extern void, U32, right? Oh, and this takes a U32, so capitalize. And right here, we'll just say define EV extern void. And now I got 6 defines here. And then down here, we'll undef EV, so... Okay, so... nested functions, so we see EV here. 2528. 2528. Okay, so this is a... we screwed up something somewhere. Two, 5, 2, 8. Well, 2528 is extern void. Is there something missing here? Oh, hold on. So this is not extern void. That's a force of habit. Let's call this EU. Extern uint32, right? And I think that'll work properly. Extern uint32, right? So then, yeah, I'm wrong there. Okay. So now, if we run that, assertion fail, that's great. Okay, line 107. So the first thing we want to do is if an assertion fails, or sorry, 1007. If an assertion fails, the first thing we want to do is change the assertion. So 0 is greater than or equal to U32 length. So since this assertion failed, we're going to say, you know, if right, so this length should be, this length, if it's less than or equal to 0, we have a problem. And we'll just change this to air. Right. And we'll say bad U32 length, and this is the function it's coming from. U32 array, right? And then we'll give it another run, and there's a possibility we just wrote that assert wrong. Also, we have to define error here. So ERR is going to be AAC 2020 PHEXDUM halt 04. And then down here we have to undef error as well. Okay. So we got another assertion that failed. Not where I thought it would be. So let's go to 950. And maybe we just wrote those assertions wrong because we just weren't paying attention. We cut and pasted code. Like the length is less than or equal to 0. So that's obviously incorrect, right? So the assertion is just wrong. So we may want to just flip that around, but we're already here, and it's kind of like, if I have to fix it, I want to make it more robust. So even though we could just flip this around and be done with it, I want to make it more robust if I'm fixing it. So, so we're going to just say that, you know, if less than or equal to 0, and just say air bad UO8 length, and then we'll take this function name. And then we'll try to run that and see what else happens. Lazy unit test ran, so holy crap, I did not expect that to... Did not expect that to actually work out of the box like that. I am shocked. Let's just make sure that that we actually have things on disk. So we have 1 PNG, 1 TXT, 2 PNG. So if we look at these PNG files, oh, there we go, 1 PNG, 2 PNG, good. And if we look at 1 TXT, beautiful. So that, yeah, our unit wow, okay. I did not expect, so usually when I write test code, I expect something to be broken, right? Like there's a saying in test-driven development. I'm not like a complete fan of test-driven development. I hate a lot of things about it, especially like writing your front-facing API first. I think that's stupid, but test-driven development does have a thing about, right? It's not test-driven development, but there's a saying, you know, if it doesn't have tests, it's broken. And while that is, you know, anything that kind of, any saying kind of like that is not always true, but it's a good, when you're in a line of paranoid thinking, I think it's a good saying. But I guess not in this case. I guess we wrote the test and it worked, but we also ran the code and verified that it runs. We've already ran the code and manually verified that these functions work. The purpose of writing the tests is just to make sure that if the code ever changes, we will know. Like if we, the tests are going to prevent accidental breakage. So it looks like we just had to put the file names in here. So 001.png, 001.txt, and 002.png. So for completeness, we might as well put 002.txt, even though that doesn't exist. And then if we go over here and we get status, ooh, that's what we could do. We could look at the number of arguments and only run it if the number of arguments is 0. I actually like that. So that way we can have a way where the unit tests don't get invoked when we try to use the utility. They just get used when we try to compile. That would probably be nice. I like that idea. So for this unit test, we're going to go in here and if the argument count is less than or equal to 1. Sure. Okay. We're gonna do that. Compile that. Unit test still gets invoked because no arguments. But then when we do .exe and we do, let's kind of open up another file. Let's open up the kind of default file here. And let's say, you know, PNG convert to naked array, and then we're going to do logo.png. Right, so we get this hex dump here, and now it's there, right? And now we can do the opposite, where we do the naked array converted to PNG, and then we just take the input PNG or txt.123, and it says we'll save to disk, because we can't really print that out, because it's like a PNG file, right? And then we can look at this, we can rename this, right? We've done this a few times, but let's just confirm this. Yep, there it is. Okay, so let's delete this. Let's delete these. Actually, let's not delete these first. Let's I just want to make sure that those PNG files don't show up. Git add dot, git status, git push, git master. Did I commit? I did not commit that, did I? Git commit -am. Okay, so push that up there, and git remote -v. So this is actually on kanji. Oh crap! Since this is on a kanji coder, I don't think I get contribution. Oh no, but I'm doing it as Heavy Metal Cookies, so I think I still get contribution on my main account. Better find out, because it's almost midnight, and I want to make sure that contribution graph has something for everything. For every day, I want, like at least one commit on here. Yeah, so today is February 5th. Is it February 5th? Yeah. So just want to make sure I have contribution on every single day, alright? I don't want these little holes. So I have missed some days, but I'm trying not to miss any days. So, okay. So, what has to be done next? So, do I really need the C99 parsing? Where I take... Do I really need something where I take, you know, U32, my data, right, with some number in here? I don't know what the number should be, so let's... Right, do I really need this? Right, do I need something like this, or is this a waste of my time? Or is it really easy, so don't worry about it, just make it because it's not that hard and we already programmed all the interface for it, so why not? So the problem with this is that we have to come up with a name for the array. And it doesn't really seem necessary. Right? To make it isn't too hard though, right? We just have to say to put together this little header isn't too hard, right? To put this together correctly, that's not too hard. And then to parse this out, all we have to do is figure out where this is and figure out where this is, and then just cut out all this and then use the parsers that we already made. So I think we might as well finish it. But I don't want to finish it right now. I just wanted to write a little bit of code, right? To not, I want to write a little bit of code every day, kind of a thing. So I'm done here for now. I think that that's a good little little benchmark, and I'll have this utility done. Hopefully I'll have this utility done by tomorrow. Okay, yeah. So I am gonna say that I'm done for now. That I did all my exercise for the day. And I wrote a little bit of code. I'm good. So I'm out of here. This was working on the PNG PHEXDumper. This is part 59 of the PAINT5D sprint, which is not really much of a sprint when it's more than half of the videos I've recorded so far. It is still Friday. Yep, it's Friday, and the video number is 127. It is 127, so we can put this down here for a second. Yeah, so it's 120. How does that work? Hold on. Oh, that's what I meant. So the video number is 127, so like if we look at the video number at the bottom of the screen right here, it's video 127 and it's Friday, right? So let's get out of here. Later.